So this today and tomorrow, that we're dedicating a couple of days to now long division that is harder. My assumption at this point in time is that you're either done or close to done with that first assignment, where we just introduced ourselves to that repetitive process. There was nothing tricky about that. The intended purpose was to get you acquainted with the process. How many times does this go into this? Stick it there, multiply through, stick it there, change the signs, drop it down, start the process over. That was the purpose of Wednesday and Thursday. Okay. Which leads us to today. And I have 4 examples. I can't cover every possible scenario in a lecture that won't just destroy your brain. So I'm going to do these 4, and I hope that that it serves its purpose. There are 2 new things you're going to see today. Number 1 is you're going to see remainders. You can just open it if you want. If you just get it done quick, it just is like tearing off a Band-Aid. It's like 5 seconds of annoying versus 2 minutes of crinkling bags. It's all good. There you go. Get her done. So the first thing you're going to notice is there are remainders today. And then the second thing you're going to see is on the very last example, there's going to be a missing term. So those are the 2 big goals for the day, is can I get you to understand what to do with a remainder? And then number 2 is, can I get you to understand what to do when there's a missing term, like a gap? So let's get to it. So for our first one, we have a divisor of x plus 4 and a dividend of 4x to the third plus 20x squared plus 19x plus 18. So you look at this and think, well, gosh, didn't I just do, what was it, 10 of these last week? Yeah. And you won't feel much burn on this example because the only thing that really is different happens right at the end. So let's get to it. So what is my first consideration when I start out on this journey? That's it. How do I make x become 4x to the third? So again, color coding for your educational convenience. The question is, what do I have to multiply this yellow thing by to turn it into this yellow thing? And the answer is 4x to the second. Right. So I need to multiply it by 4 because there is no 4. And I also need to multiply it by x to the second because I need a couple more x's to get it boosted up. Right? And then, of course, I'll put these parentheses around. And my next step in this process is to take that red thing and now distribute it down through the divisor and change my signs as I get my answers. So the first distribution gives me 4x to the third, so I put negative 4x to the third. The second half of the distribution would give me 16x squared, but I put minus 16x squared. Remember, the changing of the signs accounts for the fact that we're subtracting at this point in the process. So I'm going to cancel out these. If they don't cancel, you just wasted your time. It's the whole point is to see opposites right there. And then when you add these together, 20 and negative 16 make 4. So I have 4 of those x squareds left. Drop the 19x and begin again. So my question goes back to being the same thing it was 2 minutes ago. What do I multiply this yellow thing by to turn it now into this new yellow thing? What is the answer? 4x. Very good. So I'm going to add a new thing up here to my quotient. And I'm going to start again, and I'm going to take that red 4x, the new kid up on top, and I'm going to distribute him down across into the divisor, changing my signs as I get my answers. And so that is going to be, what is that? 4x squared. So I put negative 4x squared. 4x times 4, 16x. So I put minus 16x. And again, if you don't see the cancellation happening right here where I'm moving my pen, then you're just wasting your time. That's the whole point is bye-bye. And then what do I get when I add these x's? I get 3x, and then I drop down the 18, and I repeat the process again. So question again is, how do I make this yellow x become this yellow 3x? And the answer is I multiply by 3. So up now into the red area, the quotient area, I'm going to add a +3. And I'm going to distribute that red 3 through the purple parentheses, multiply, change my signs as I go. The first one would be 3x. So I'm going to write minus 3x. The second one would be 12. So I'm going to write minus 12. And now for the first time in our workings, this becomes normal. I'm not saying that this will happen every time, but I'm saying that it's now in play. And you can expect now that this doesn't necessarily mean you made a mistake. What this means is now we're doing problems that have remainders. So when I add these together, my 3x's of course cancel. But then when I add the 18 and the negative 12 together, I get 6.
This one, what I say, with on top of them with a remainder of 6.
The way you write it is like this, because I'm going to write this down because you're going to see this in Delta Math and go, what does this mean? So I'm going to give you an abbreviated version of this. Your answer needs to be expressed as Q plus R over D. And this goes back to the vocabulary that we learned on day 1 back on Wednesday. Do you guys want to guess what Q stands for?
Quotient.
Quotient. Good job. So I'm going to do quotient. So here comes my answer. I'm going to write it in green for you so you can see it over here. My answer is quotient plus, and what does R stand for? Remainder, which is what? Over D, which is divisor. So this is how your answer would be expressed when there is a remainder. And again, that is, let me color code this for you. That is the quotient. This is the remainder. And this is the divisor.
What did I just do?
If you think that that's new, I hate to burst your bubble, but you've been writing answers like that even since back in the 4th grade. When you guys did long division problems, you wrote it just without the plus sign. Let me give you an example so maybe you'll buy it and go like, wow, I really have done this before. Let's say that we did 44 divided by 3. Follow along. You'll be like, oh, I've done this before. 3 goes into 4 one time. 1 times 3 is 3. 4 minus 3 is 1. Drop the 4. 3 goes into 14 4 times. 4 times 3 is 12. And your teacher way back in the day, probably some of you, had you write it like this: 14 and 2/3. You can see it for yourself. There's my quotient. There's my remainder. And sure enough, there's my divisor. So Q plus R over D. Got it? What's that? Was it? Did that make sense? Good. Glad. I like feedback like that.
I'm gonna start giving you some feedback in your class.
Hey, tell me if you think this is a good idea. So I was on the internet the other day, and I like to sometimes go on Reddit. If you don't know what Reddit is, you should eventually, as you get older, you inevitably will discover what is Reddit. It's beautiful. It's not a social media platform like Facebook where everyone's up in everyone else's business. It's often more of a conversation or an idea sharing forum, not a judgment forum. And anyways, one of the subreddits that I subscribe to is teachers. Because sometimes it's nice just to hear other teachers having the same exhausting problems that I have, and it's nice just to share stories or to get ideas. But anyways, this teacher had an idea. I've jokingly said in the past I should put a comment box like on the way out the door. But the problem with a comment box is, first off, there'd probably be some kid who on a card would just write like, I like poop, and drop it in the box. You know that that's going to happen. Or someone would draw like a picture of a wiener or something like that. So the comment box is something I've toyed with, but I don't really do it just because I don't want to deal with the murderous rage I would feel when a kid does that. So this guy came up with this idea. He has this anonymous online teacher input form that students can fill out, and it doesn't give any information to other students. And the student can also choose to have the form not even show the teacher what their name is. and they can give input to the teacher completely anonymously, digitally, where no one else knows that they're doing it. Don't you think? Yeah, theoretically, I mean, you could, if you really were good with like ASCII and symbols, you could draw a wiener. But like, really, in theory, don't you think it's a great idea? So like, kids will sometimes say things, they'll give input that I wish I had heard 5 years earlier. But then I'm like, well, how would I have known? Because no one ever freaking talks to me about this stuff. So if you ever have input, like, I'd love to hear it. If it's serious, right? No, never mind. What's that, Dietrich? It is a great idea, isn't it? All right, let's get to it. Here's our next problem. So the question is, again, I'm going to just keep using yellow. I try to be consistent with my colors. What do you have to multiply yellow by to turn it into yellow? Good job. So the answer is 2x squared. So I'm going to place that up into my quotient, and I'm going to distribute that through the purple parentheses, changing my sign as I go. I'm going to just do each of these problems, this times this, and this times this. And as I answer them, whatever answer I would have gotten, I'm going to write down the opposite of it. Got it? So for the first one, I would get 4x to the third. I'm going to write minus 4x to the third. For the second one, I would get 6x squared. I am writing negative 6x squared. Then I'm going to draw a little line here to tell the world I'm sealing this off. I'm going to prove to myself that I did it right. Those are going to cancel. And then I'm going to add the white and the purple together. What do I get? Cool. Actually, the purpose of this example was not the remainder. This one, the purpose was, I don't think I've given you any yet where there was a number right there. Have I?
Yeah.
Oh, you've already seen this?
Yeah.
You lucky turkey duckies. Well, let's finish it off.
So you're going to take
Now we have to drop the minus 13x down, and let's start over. What do you multiply yellow by to turn it into yellow? I'm not going to take close answers. Yep. Close answers do me no good. Negative 9x is what I need up here in the quotient.
So you take whatever number would make negative 12x squared.
Negative 18x squared.
Oh, okay.
I'm trying to turn this into this.
So taking
Yes. By making that, I guarantee myself that I will put something in this yellow box that will cancel with that. Does that make sense? Nice. So to make yellow into yellow, we had to use a negative and a 9 and another x. And now again, we're going to redistribute. And as we redistribute that through, there's just so many opportunities to screw these up. So we have to just be careful. So we're going to take what I'm circling up there in purple, and we're going to multiply it. We would get negative 18x squared. We're going to write plus 18x squared. For the second half of it, we would get negative 27x. We're going to write plus 27x. Seal it off. Verify. Yep. Cancellation. Add those together. You get 14x's. Drop the 21. Say it again. Yep. So we are going to, again, I just consistently use the colors because I would like it if someone had used colors when I was young. So I use them because I think it can't hurt. So I'm asking you to turn that yellow thing into that yellow thing to make a carbon copy of it. What do you have to multiply the high one by to make it into the lower one? 7.
Wait, no.
You have to don't overthink this. Don't start thinking about, oh, you have to make it negative. You got to just make it turn into the other one. Make 2x become 14x. And the way you do that is by multiplying it by 7. Got it?
I mean, never mind.
Yeah, it would have been a positive, but we switched it to a negative. Yeah. Yes. From this multiplication problem right here. Negative 9x times 3 is negative 27x, but we have to switch the signs because we're subtracting. So all the signs get changed. Which leads me then to this, and I'm with Micah on this one. It doesn't look like we're going to have a remainder here. So we're going to now take the newest addition to the top in the red line, and we're going to distribute him through the parentheses, and we're going to change the signs as we go. So that would be a 14x, not us. 7 and 3 would be a 21, not us. So this problem turns out there is no remainder. So when I write this answer, I don't need to use q plus r over d. My answer is just like it has been, 2x squared minus 9x plus 7. Right? That's still good? Okay. I've got 2 more examples. This next example sucks for its own reason, and then the example after that sucks for a completely different reason. So if I've lulled you to sleep with my mathematical croonings, I hope you wake back up. I don't see the need. I know, easy for you to say, right? The only time I feel like I have to raise my voice is when this stupid thing kicks back on here in about 21 seconds, and then.
No, it just needs to stay close.
What's that? Nice.
When you.
I will say this, that I will often choose whether or not I want to listen to an audiobook based on who the narrator is. I will tell you right now, if it's someone from like Ireland or Scotland, or I am all in. I could sit and listen to those people read the dictionary to me. So there it comes again. Thanks a lot for that. Yeah, appreciate you. You think I wouldn't have done that by now, Shariah? It's like, oh, why didn't I think of that? Just turn it off. I have no control over that device. Now I can do this. Oh, well, gosh, why didn't you just do that? Wait for it. I've got no control over that device. Oh, what's that? Oh, you're right back on.
Note to yourself, bring a switch up to this class.
For me, it's not about, I love the cool air. It's that noise. I hate the noise of it. No. Yeah. Eventually, I think now that we're getting to the colder months, if it still behaves like this, I'm going to ask that it be.
Well, I'm surprised because I can turn Windows off. I just pressed the button.
Well, I just wanted to demonstrate to you that when I press said button, that it doesn't go
That
off.
light? Remote button?
I've been told that the remote has no interaction power with the air conditioner.
I turned Windows off of it, so.
Oh, maybe I'm gonna try that. You notice right away now that our divisor is not a binomial anymore. Our divisor is a trinomial. So again, lots of opportunities to make mistakes, or you can look at it from the other side and say, lots of opportunities for me to prove to the world that I can do 10 minutes of straight, flawless mathematics. So here
10
we go.
minutes? This is going to take 10 minutes?
So the rules don't change. The same thinking is still in play. I ask myself over and over again, how do I turn this into this? And I eventually will quit using yellow circles, for God's sake. So what do you multiply that yellow by to turn it into that yellow?
4.
And the answer is I need a 4, and I need some more x's. I need 2 of them, right? Great. So now I'm going to take that 4x squared, and I'm going to distribute it all the way through this longer divisor now. I'm not scared. I'm going to take my time, multiply correctly, and change the signs as I go. So You don't need to. Where you put it is unimportant. That's a good question, but relatively up here where we put it doesn't make a difference. So let's distribute. What would my first one be that I'm going to write down? Well played. Second one?
Negative.
Nice job. Negative 24x to the third. And the last one?
Negative 4.
Good job. So again, we're changing the signs as we go so that we don't have to do it later because it's a pain. As I showed you in that first example last Wednesday, changing it later is a pain. All right, let's add some like terms together. The x to the fourths are going to cancel. How many x cubies do we get?
Negative.
Yep. 15 minus 24 is negative 9. And notice this time I've got a little extra work to do, right? Before I get ready to drop down the next guy in the queue, I've got another math problem to do.
Negative.
Nice job. And at this point now, to fill the space, I'm going to drop down the minus 19x, and the algorithm has 0 ground reset back to the beginning. So in keeping with tradition, how do I turn yellow into yellow?
3x.
We definitely need to multiply it by a negative. And I need to multiply it by another 3 and another x. Good. Same, 19th verse, same as the first. We're going to take that thing up on top and we're going to distribute it through and hope and pray that we don't make a single mistake, which is a tall expectation with this much to do. So negative 3x is being distributed. The sign will always change to the opposite of whatever you would have gotten. So like if I drew this purple arrow right here and said, just multiply those, straight up multiply them, what would you get? You would get negative 9x to the third. And then you change the sign after that. So we are going to write plus 9x to the third. And you do it again. I'm not going to give you rules about, so you change it to a negative or you change it to a positive. I will tell you again and again and again, you change it to whatever the opposite is of what you get.
That would be negative 18.
Exactly. So plus 18x squared. And then the last one,
What came up with this?
it would be negative 3x, right? So we're going to write plus 3x. And then we're going to get ready to reset again. And you know that we're one step from done because there's only one fella left in the queue, and it's that lonely -1 back there at the end. So
Minus
gonna-
1. Negative.
-1, -1, call them whatever you like. Let's cancel out some x cubies. And how many x squareds do we get? Negative 12. And then drop down the -1. And we know we're on the last iteration of this because, again, we're out of guys to drop. So again, what do you multiply yellow blob by to turn it into other yellow?
4.
It is not 4. And those are the little things we say that just can't slide. It is -4. Every sign counts. Now, when I multiply that -4 through the purple parentheses, I stop and say, this is what I would have gotten, and then I quickly change before I write it down. So the first one would be -12x squared. I write plus 12x squared. The next one would be -24x, so I write plus 24x. And the last one would be -4. I write plus 4. And now let's see how we do as far as a remainder is concerned. So let's cross off the part that we know is going to go, and whatever's left is left. How many x's we get? Good. So remember, we're going to write our answer as q plus r over d. So what goes on the first line, the first part of my answer? Quotient plus remainder over divisor. So quotient first. So 4x squared minus 3x minus 4. And then I'm just going to put plus, and then I'm going to draw a fraction like this. That fraction is like remainder, stick it up on top, divisor, stick it down on bottom. So the vocabulary does come in handy so you know who goes where. What's the remainder? And what's the divisor?
3x squared plus 1.
That's that. Quotient plus remainder over divisor. Last example, I promise. One more. Oh yeah, that one took 6 minutes and 34 seconds. Well, 6:30. Not bad.
Yeah. I just didn't think it would take 10 minutes.
I was just guessing. I didn't know.
But you know.
Oops. Think that. There we go. I could make this lesson take a lot longer if I really wanted to try to cover every possible scenario, but you're going to have to sort of extrapolate from this lesson some things that can apply to other problems. So there's something in this problem that we have to fix before we can do it. And I don't expect you to know what it is, but I would be curious to know if you have something, see something that makes you go, It's something to do with the divisor. There's something wrong with the divisor. It's missing a term. And you might think, like, who cares? You should care. Trust me. The reason I care is because if I don't fill it in, then as I'm working through the process, things start not lining up with each other. And I'm not saying that you have to put in the missing term, but if you don't, it gets a little bit weird. So my advice to you, and when I do this on the board with you, I will always plug any missing terms with 0 of that type. So where it says x squared minus 4, this is what I'm going to do. I'm going to take this x squared and I'm going to move it over here to the left, and I'm going to put in a missing term of plus 0x.
Oh, like that.
I didn't think you would like that, but you're going to like it a lot less if you leave it out. So get it in there. And that way there, every step of the dividend is accounted for. I got x to the 4, x to the 3, x to the 2, x to the 1, no x's. And then in my divisor, I got x to the 2, x to the 1, and no x's. You don't want to leave gaps because things don't match.
That just looks weird.
Is it because I wrote it in red?
No.
Here, I'll fix it. Does that look less weird?
No.
No.
It's just like it's telling us so putting a 1 in front of the X. That's
But
just,
zero,
The
That's just
0
weird.
actually serves a purpose in this case. I hope you see the purpose. And if you don't see the purpose, then you should go and try this problem later without the 0. And maybe what you'll discover is Mr. Ahern was wrong. I did the problem just fine without the 0x. And that would be cool for you. My experience just tells me that if we don't have it, weird holes get created and things stop matching. So let's go. How do you turn yellow into yellow? You multiply it by 3x squared. And then we're going to multiply through, distributing, changing the signs as we go. So what's my first answer going to be? Good job. Negative 3x to the 4th. How about my second one? And this is the one that might drive you nuts, but it really does help. What is that answer right there? It is 0x to the 3rd.
well, if you
Remember that anything times 0 equals 0. And the reason I have you do this, and you can debate it with me if you want, and there's a 61% chance that you'll win the debate. So don't, it's fine. I like to have a term now that matches with the other one like him. So I right here, I'm going to put plus or minus, doesn't matter, 0x to the third. That way there, that negative 9x to the third has a buddy below him to combine with, and everyone stays in line with their homies. That's the goal. Now let's take this distribution right here. The yellow arrow indicates the last problem, which would be negative 12, but we're going to put plus 12x squared. Good. And now we're going to cancel out what we set out to do. We're going to add these together. You can see at this point, I'm circling this for you. It wouldn't have mattered whether I put plus or minus. Adding none of something and taking away none of something just doesn't serve me. Like you're not going to get different answers. So I'm going to bring down my negative 9x to the third. And I'm going to add those together and get negative 2x squared. I'm going to drop down the next guy in the queue and repeat. How does x squared become negative 9x cubed? Good job. You have to multiply by negative 9x. So let's stick that up there. So we're going to take that negative 9x and distribute it through the divisor, changing signs as we go. What will my first answer be? Good job. Positive 9x cubed. So I'm going to put a plus 9x cubed there. How about my second one? Yeah, plus or minus doesn't matter, 0x squared. And that 0, I understand, might drive you nuts, but it serves a good purpose to keep everyone structurally in line. That's all it does. And then the last is?
It would be negative 36.
It would be positive 36x because it's a negative times a negative. So because it would have been a plus 36x, I'm going to put minus. Negative times a negative. And then I'm going to seal it off, combine like terms. I get negative 2x squared. How many x's will I get? And then we drop down the final guy. And let's see what happens. Once again, might as well, why stop now, right? How does yellow become yellow? Got to multiply by negative 2. So watch out. These are the ones that we like to miss the most. When we have a negative up in the quotient, we tend to overlook things. So be patient with it. Multiply one step at a time. What's the first answer down below going to be? Going to be this times this, which would be negative 2x squared, but I'm going to put plus 2x squared. Now, continuing on, take that red negative 2 and just keep smacking them through the divisor. So next up is negative 2 times 0x, which is like 0x. So put plus, put minus, doesn't matter. And then finally, what is negative 2 times negative 4? Positive 8. So we're going to write minus 8, right? And you can see clearly here that we are indeed going to have quite a remainder. So we have negative 6x plus 6. So again, our answer needs to be expressed as quotient plus remainder over divisor. So what's that going to look like for us? So just minus 9x minus 2. And then I have to put plus, okay? Make sure you put plus. And then, yes, draw your fraction line. And then what? And I want you, good job, by the way. I want you to notice that I didn't put what Peyton said quite on the bottom. I took the 0 out now because it no longer has any functional purpose. I needed it through the meat and potatoes of the problem. If you don't like it, just stop complaining about it. At the end, I can take it back out because his purpose has been served. So that's that. You're going to find some other sorts of little individual scenarios that pop up, and I'll just try to address them as they come up. The key is if you see any missing holes, fill them in with a 0x to the whatever's missing. And then, of course, now you know how to deal with remainders. So there is a new assignment for you on Delta. I think it's assignment, I don't know, whatever's next.
I have a question for you.
Got it? So I'm going to pause the old recording here. So I'm going to figure out what do I multiply that yellow thing by to turn it into that yellow thing. The answer is
Yeah.
what is the answer? So, great job. Great job. So now we're going to take that red thing and we're going to distribute it through these purple parentheses. So 2x squared gets distributed through the divisor, which is right there. Nice job. So you have to stay organized, okay, kids? So you've already done this one. Now it's time to do this one. Keep track of where you are. So now when you multiply that second yellow arrow, you would get what? You would get negative 4x to the third.
Oh.
Because you have 1x joining with 2x's to make 3. So because we would get negative 4x to the third, we're going to write 4x to the third. You guys might want to follow along with this one. Whatever you're doing on your Chromebook or whatever, you might want to stop. Because something's about to happen.
Oh, God.
It's not, listen, this is the kind of thing I was talking about. Maybe I should have just put one of these in the lesson, but it's better just to encounter it in the moment. But if you're on your phone or on your Chromebook or taking a nap, come back to me because this is one of those little weird scenarios I was telling you is going to pop up. This is Peyton's problem, and I am recording this, and Peyton asked a question, and then it turned into let's just do this whole problem together. And I'm really glad that we did because something weird is going to happen. But it's not bad. It's just a little weird. So Peyton and I are in the middle right now. We found our first part of our quotient and we're distributing it through and we have done 2 out of the 3. This third one right here would be minus 6x squared. So I'm going to put plus 6x squared. When you add these together, you expect those to cancel. What you don't expect is for those also to cancel. You get a bonus cancel. Got it? Which is actually a really good thing if you know what to do. So let's continue on to the right. Let's add these x squareds together. What's negative 7 plus 6? What's negative 7 plus 6? Negative 1x squared.
What it only
Yeah, negative x squared or negative 1x squared. I didn't hear you say negative. I'm sorry. Did you say negative? Oh, I'm sorry. I didn't hear you. Yes, it's definitely negative. And then I'm going to drop down the plus 10x. And I'm also going to drop down the plus 9. I dropped down 2 things this time because it's okay. Since I cleared out a space, I can do double duty and pull down doubles. I'm not done with you yet. I'm not done with you yet. So the next thing I'm going to do is go back now and ask myself, how does this become this? But I want you to notice something, that if I go right to this question, which is fine, I'm kind of skipping over something. So I want you to kind of take mental note of that fact that how many times does x squared have to get multiplied to become negative x squared? What do you have to multiply yellow by to turn it into yellow? Not 1. So watch, just negative 1. I don't even need any more x's. We're so used to up here in our quotient having our first one be x to the second, and then our next one is x to the 1, and then our last one is just a number. In this case, I actually bypassed an entire part of my answer. Do you see?
I do see the
Sure.
can you only this is dumb, but can you only drop down to 2 if only 2 cancel?
Yes, if 2 cancel, basically,
You
look,
can drop down 2 because you drop down the 9. That's like
really, this is a smart question. Everybody listen. Peyton's question is spot on. She said, how do I know when to drop down 2? Here's my answer to you. You see how long that thing in the yellow is? How many terms does he have? Then always make sure you've got 3 in the queue, like loaded up in the chamber, right? So, yep, you want to have a match for everybody. So if you got 3 out here in the divisor, make sure your guys in here always have 3. That's why if you cancel 2, there's only 1 left. You got to drop down 2 more to make 3. You got it. Make sense? All right. So let's finish this. That was what I wanted you guys to see, is that you're going to sometimes have things that get skipped. And it's a good thing if you don't panic. Just know what to do. So now let's take that -1 up here. I'll circle him for you. And let's distribute him through there one at a time. Nice job, because you switched your sign, didn't you? Is that what you did? Good. Now keep going.
Also, I have a 1x. Can I just
Sure. Go ahead.
I call placement graphs.
That's call them whatever you want and use them if they help. I don't care. Next one. But we're not going to write that.
We're going to get a +2x.
It would be a +2x, but we don't write what we get. We write the opposite of what we get. You have to let yourself experience that. Yes, because the normal answer would be +2x. We write minus.
This one, I make it +3, right?
Now we're cooking at a kid. Yeah.
And
So
then
we'll-
these 2 can be 8x +6.
So now what we have to do is figure out how to type it into Delta Math. And so we've got it all. That's it. We're done because we know that, see up here, you know you're done. You've exhausted. There's no more guys over here. There's no one to drop. So we're done.
So what I just put, quotient plus remainder over
Divisor.
divisor.
Yep.
So I would put 2x to the second minus 1 plus 8x plus 6 over x to the second minus 2x minus 6.
Yep. Let me watch you type it in. But I'm still recording. Just I don't know why, but I'm just going to keep it going for another minute.
I forgot. Get me your flex, but I'm not sure. I'm taking work keys tomorrow,
I remember. Yeah, I got that email.
so I don't know how long that's gonna last.
I think work keys, they said you should be done before flex, but I'm not really sure. Maybe even done during 3rd hour. Well, yeah, I'll keep
Yeah,
you in
they
there.
didn't really know.
I'll keep you in there for sure.
Oh.
By the way, Peyton is experiencing something right now. Again, I know you guys have checked out and you're done listening to me because class is over and now you're on your phones. If Peyton wants to take, just stop typing for a second, look up here and get closer if you need to. Peyton is in a bit of a predicament here. So could you hit backspace like twice or once? Good. So now type in your 6. So what Peyton's trying to do is she's trying to put this into the computer. She wants the 8x plus 6 to go over x squared minus 2x minus 3. But after the 6, when she hits divided by, it just keeps dividing the 6. Do you guys know how to make the whole thing go on the top of a fraction? You can use the keyboard or get rid of that x on that 6. What are you doing? I want you to watch what Peyton's about to do. She's going to grab with her mouse. She's going to grab the 8x and plus 6 and drag and highlight 8x plus 6. Watch this.
Like that?
Yes, now hit your divided by sign. Look at that.
Whoa.
So if you highlight the whole thing and then hit division, it'll put it on the top. You also could use parentheses, but that's way less annoying to do it that way.
Is that what correct you?
No, you forgot the x on your divisor. X squared minus 2x minus 3.
So I put
And that sucks because like you're so close, you'd hate to miss it because that I think that looks good.
Okay, cool.
Send it.
Awesome.
Jackpot.
Thank you.
You're welcome.
I still look so different this year. So
I don't know. They revamped it, so it took me a while, but I'm okay with it now. So,
Thanks
all
for
right.
that.